Okay. The OSI model. What is the OSI model? The Open System Interconnection Model, otherwise known as OSI, is the fundamental model used in networking. It provides a framework dictating how all the network devices will send, receive, and interpret data. Data encapsulon is when a data is from the application layer and is encapsulated in a format specific to that layer. As it moves down the OSI model, each layer adds its own header and possibly trailer information to the data. The main benefit of the OSI model is that devices can have different functions and designs on a network while communicating with other devices. The same data is sent across a network that follows the OSI model and can be understood by other devices. So there's 7 layers in the OSI model: application, presentation, session, transport, network, data link, and physical. Let's start with application. So application is a layer in which protocols and rules are in place to determine how a user should interact with data sent or received. Applications such as email clients, browsers, or file servers provide a graphical user interface, otherwise known as GUI, for users to interact with sent or received data. Layer 6 is presentation. This layer acts as a translator for data to and from layer 7. The receiving computer will also understand data sent to the computer in one format designated for another format, I believe I wrote. Sorry. For example, if you have a Google email account and are sending information to someone with an Outlook email, you may have different emails, but the contents of the email will display the same. Layer 5 is session. This layer synchronizes the two computers to make sure they are on the same page before data is sent or received. Once completed, the session layer will divide up data sent into smaller chunks of data and will send each chunk, otherwise known as packets, one at a time. This happens in case a connection is lost and all the chunks won't have to be sent like all over again, basically. So just saves your data. Sessions are unique because they can only travel over their own session. Layer 4, transport. So this one's a pretty long one. This one I think I had the most challenge getting my head around because there's so much to it. So layer 4 is transport. This is the most vital layer for transmitting data across the network. When data is sent between devices, it follows either a TCP or UDP protocol. So we'll start with TCP. The Transmission Control Protocol reserves a constant connection between two devices for the amount of time it takes for the data to be sent or received. So some advantages of TCP is that it guarantees the accuracy of data. It's capable of synchronizing two devices to prevent each other from being flooded with data, and it performs a lot of processes more reliable. Performs a lot more processes for reliability. So sorry. Some disadvantages of TCP is that it requires a reliable connection between two devices. If one small chunk of data is not received, then the entire chunk of data cannot be used. A slow connection can bottleneck other devices, as the connection will be reserved on receiving computer data the whole time. And then TCP is also significantly slower than UDP because the network makes it do more work, and it's done by the devices using this protocol. So this is what a good example of TCP would look like. So it sends them in small packets. So if we're sending a cat over, it's 3 packets divvied up to make the whole thing. It's like a puzzle. UDP, also known as the User Datagram Protocol, is not as advanced as TCP, as it doesn't have an error checking or reliability. However, there's still many benefits to it. UDP is faster. UDP leaves the application layer, which is user software, to decide if there's any control over how quickly packets are sent. And it doesn't reserve a continuous connection on a device like TCP does. Disadvantages is that it doesn't care if data is received. It is quite flexible to software developers in this sense, I guess. And this also means that unstable connections result in a terrible experience for the user. So you better have good connection, basically. So this is what it might look like. You send in packets, but if one isn't sent, then you're still going to have a missing image to the receiver. But yeah, this is probably the hardest one just because there's a lot to do. Layer 3 is network. Kind of went over this in previous videos. But this layer consists of routing and reassembling of data. Essentially, this determines the most optimal path in which chunks should be sent. This includes the open shortest path first, which OSPF, and routing information protocol, RIP. Everything in this layer is dealt with IP addresses, so router capable of delivering packets use IPs and are known as layer 3 devices. So basically the routers and stuff are known as layer 3 devices because they're capable of working the third layer of the OSI model. Layer 2, data link. This layer focuses on the physical addressing of transmission. It receives a packet from the network layer and adds the physical MAC address of the receiving endpoint. Inside every computer that has a network, there is a network interface card, NIC, which comes with a unique MAC address to identify it. And layer 1, obviously the hardest one, is physical. Pretty easy. It's just components that are actual hardware that use networking, that use electrical signals to transfer data. So basically binary numbering systems, and Ethernet cables are a perfect example of this. So the game is just asking you if you know your layers, basically. So you start from the bottom, which is physical. You have to press space to go in, which I did not know for the longest time. I was trying to figure that out. And it's data link. Then you have network, transport, session, presentation, and finally application. And that is the OSI model. And next will be packets and frames.